In this video, we're going to look at two ways to represent sets. Let's bring back our common sets from the math world. What do you see on the left and what do you see on the right? Do you see a difference? On the left, you have the list of numbers, and on the right, you have the names of those lists. What do we call these lists? The first one is the set of all natural numbers, then we have the set of all integers, and so on. The key difference, the way I like to think about this, is on the left, you have answers, and on the right, you have questions. These are the two different ways to represent sets. Either you can say that 1, 2, 3, 4, and so on is a set, or you can say that, well, we're looking for a set of all natural numbers. Both of them work. And the technical terms that we use are roster method. Whenever we list down answers, we call it the roster method. And set builder method. Whenever we use questions, we call it the set builder method. Let's look at both of them more closely. Roster method first. Let's say we're looking for all odd positive integers less than 10. So the first thing that we need to do is we need to put brackets. And not just any brackets, we use curly brackets. These are brackets, and we put our answer between these brackets. So what's our answer? Well, we have odd positive integers. We need to take 1, we need to take 3, 5, 7, and 9. No more than that, because we want integers less than 10. So these are our answers. We call them elements, and we separate them with commas. A quick note, what we could have also done is written this answer, written the list of elements in a random order. I could have written 1 here, 3 here, 5, and then 7, and then 9. Again, commas, and it would have still been okay, because the order does not matter. All we care about is whether the elements are part of the set or not. So 5, 1, 3, 9, and 7, they're part of the set. 2, 13, 87, they're not part of the set. So that's all we care about. Also, we don't generally repeat the elements. Making it clear that an element is part of the set once is enough. We don't have to keep repeating it. Let's do some practice. Let's say we want to write the set of vowels in the English alphabet. How do we do that? Again, brackets, and then the answer inside the bracket. We have A, E, I, O, and U, and then commas. That's the roster method. Let's look at one more. The set of all odd natural numbers. Again, brackets, and then the odd natural numbers, which are 1, 3, 5, and so on. These dots, these 3 dots, they mean that the list never ends. Alright, letters of the word school. How do we write that? Well, again, brackets, and then the letters are S, C, O, and we only need one O because we don't repeat the elements. When we have said that O is part of the set, we don't have to say it again. And then H, and then L. And also the order does not matter, so you can have O first, or you can have H first, or you can even have L first. Okay, commas. So that's how you write things in the roster method. Let's look at the set builder method now. So again, let's do an example. All positive integers less than 6. The roster method says that's how you do it. You have brackets and you have the answer inside the bracket. But what's the question? Well, the question is clear. We are looking for all positive integers less than 6. That could be one way of writing things in the set builder method. But we can be more mathy about it. Let's see how. The question is all positive integers less than 6. So the element has to satisfy a few rules. The element is a positive integer, and the element is also less than 6. It's both of them. It's a positive integer and it is less than 6. And because we're being mathy about it, let's say that the element is x. If the element is x, then x belongs to the set of all positive integers, and also x is less than 6. So what we're really saying is we're looking for all x such that x belongs to the set of natural numbers and x is less than 6. This notation is called such that. That's how you phrase it, such that. And now you combine all of these things together. This is how you write it. You still use the brackets, and inside the brackets, you write all of this. You write x such that x belongs to natural numbers and x is less than 6. You use comma if you have more than a few rules. So this is a bracket, this is your comma, and this is your such that. You first write x, then you have such that, and after this you have the condition that x needs to satisfy. This is how you write things in the set builder method. Again, think of it as a question. If you solve this question, you'll get this answer. Let's do a few examples. A, E, I, O, U. That's your answer. What's the question? Well, the question is, you're looking for all y's, and you can use any variable here, but you're looking for all y's such that y is a vowel of the English alphabet. Finally, y is not a vowel of the English alphabet. But let's continue. 1, 3, 5 and so on. What's the question? Well, the question is, we're looking for all z where z is an odd natural number. And if you want to be more mathy about it, you can say that we're looking for all z such that z is equal to 2n minus 1. That's one way to write odd numbers. 2n for even numbers and 2n minus 1 or plus 1 for odd numbers. Z equals to 2n minus 1 and n belongs to natural numbers. If this is your question, you'll get this as an answer. And you can try it. Let's put n as 1. That's our first natural number. 2 times 1 is 2 minus 1 is 1. So you get the first answer. And then if you put n equals to 2, 2 times 2 is 4 minus 1 3. You get the second answer and so on. You'll get all the answers. One final one. 1, 4, 9, 16 and so on. What are these numbers? What's the question? Well, if you look closely, these are perfect squares. 1, 4, 9, 16. And not just any perfect squares. These are perfect squares of all the natural numbers starting from 1. So the question is, we're looking for all x such that x is equal to n square and n belongs to natural numbers. Starting from 1, you'll get all the perfect squares as the answer if you have this as the question. So we have covered two different ways to represent sets. One is in the form of answers and the other one is in the form of questions. One is called the roster method and the other one is called the set builder method. In the upcoming videos, we'll practice more switching from one form to the other.